Okay, so this is question 12 from the 2020 paper. Also, sorry about the audio in the other video. I don't know why it went weird. I think maybe I connected to my headphones or something. Anyways, this is a trig question. The first one's a show that. So we have to try and make the left-hand side the same as the right-hand side. There's like, I don't know if there's only two, but there's probably like a couple ways you could do this. And I did a way that was different from the mark scheme, so I'll do my way and then show the mark scheme after. So what I did was I rewrote cosec into like terms of sine. So cosec's the same as 1 over sine. Well, not minus 1. And then the minus sign. And then I took a sine like out of this, like I turned like sine and then brackets 1 over sine squared minus 1. I did this because if you turn this into a trig thing, you would get cosec squared minus 1. And cosec squared minus 1 is the same as just cot, cot squared. So this is the same as cot squared. And then in the question, we needed cos times cot. So what I did was I separated the cot squared into like 2 cots. And then I rewrote cot into terms of sine and cos. So cot is the same as 1 over tan, which is the same as cos over sine. So if I do that, I got sine times cos over sine times cot. And then if you do that, the sines cancel out and you get cos times cot, which is the same as the right hand side. And then in the mark scheme, they did the same thing at the start. They rewrote this into terms of sine, but they turned this part into like one whole fraction that was over sine theta. So to do that, they times this one by sine again, and they got 1 minus sine squared on the top, which is the sine squared plus cos squared equals 1 like identity thingy. So they just turned that into cos squared, and then they also took like 1 cos out because that was part of the answer, and then simplified this bit into cot. And then part B, we need to solve this equation. So the first part is the same like thing in part A, and we know that that was equal to cos and cot, and that's like what's over here. So we want to use part A for this. So if we do that, we get cos x cot x is equal to cos x cot 3x minus 50. Okay, and then here I divided both sides by cos. So that was cot x is equal to cot 3x minus 50. Then you also have to remember that when you divide by like any trig thingy on like just its own on both sides, there's also another solution, which is for when like whatever this is that you're dividing by is equal to 0. So why am I writing that? So that would be cos x is equal to 0. So if you solve for x, so doing like cos inverse of 0, you get 90 and 270. But the questions between 0 and 180, so we can just ignore the 270. So just x equals 90 is one solution. And then if you go back to this, since you have cot on both sides, you can just times both sides by the inverse of cot, which will like cancel out the cots. So you would get x is equal to 3x minus 50. So you can rearrange this for x, and you would get 50 is equal to 2x, so 25 is equal to x. And then I had to check because I forgot, but the cot graph looks like this, right? So it repeats every 180, which means that there could also be like another solution for like this bit, like when one of the like x plus 180 bits might intersect with the 3x minus 50. Like, okay, so you know how the graph looks like this, right? Like, if we only do this, then like we're kind of just assuming that it only meets the 3x minus 50 graph once, but it probably does meet it like more times. I'm not saying probably, yeah, it probably does meet it like more. It's just like one of the 180 gaps. So we just need to check if like that gap is within the 0 to 180 range. So if we were to do that, we're basically saying that x plus 180 is equal to 3x minus 50. So that's like saying about 230 is equal to 2x, which is 115 is equal to x. So all the solutions would be x equals to 25, x equals to 90, and x equals to 115, which is also